Hello everybody. So this is the Q&A session. All the questions that were submitted during the webinar, and by the way, thank you very much for attending the webinar. I'm going to attempt to answer every question. But before I begin, notice the URL here. So the packet traces, the trace files, and any supplemental material from my webinar will be uploaded to this location, box.com/hansang-book. Okay, so keep that in mind. The other thing that I wanted to show everybody was Jasper told me, got a feedback from Jasper, and he's absolutely right, that my Wireshark profile from a beginner's perspective is too daunting. There's too much stuff here. And if you go to my YouTube page, you'll see the videos on how I came about and made these columns. But Jasper said that, hey, if I'm starting out, this looks like there's too much information. It looks very different than traditional Wireshark. So what I will do is I will switch over to my minimal version. Okay, in this profile, I only have the cumulative bytes and the delta, because if I don't have those columns, then I simply cannot troubleshoot. Okay, so watch the first two videos that are posted in my YouTube channel on how to set up the Wireshark. Okay, so moving right along to questions. Will the copies of slides be available? Yes, although there's not much to it, but it'll be also on the box.com link I just showed you. And the book that will be published progressively as the series unfolds. So it's not a traditional book. I'm going to just do everything via YouTube. Okay, so I'm not going to publish a hard copy. Although I've been pinged many times about, will I have a hard copy? I don't think so. So it'll be more multimedia oriented on YouTube. And that question comes to us from Moy, I believe. Okay, next question comes to us from Kim. And how has Wireshark worked on at Riverbed? So we really keep in mind that Wireshark is an open source community project. Riverbed funds Wireshark from a infrastructure standpoint, wireshark.org, the servers, the platform that Gerald uses to help develop on. Predominantly it is an open source project. I can't tell you how many times a salesperson contacts me to say, hey, I have a customer that would like enhancements on Wireshark. What should I do? My answer is always simple. It's an open source project. Talk to the core developers. Okay. Wireless. So will there be any wireless content from Becky? So obviously there were no wireless content. Wireless is slightly different because you do have to have RF experience. And for those of you that are interested, Rolf did many sessions on troubleshooting wireless. Okay. The other problem is that Windows PCAP drivers and wireless, you can't get the control frames, which is a critical part of wireless troubleshooting. So while this is a shameless plug, it's a necessity. If you go to wireshark.org, there is a Wireshark Plus or Enhanced Wireshark section where you can buy the wireless dongle that allows you to capture the control planes, okay, or the control packets from a wireless perspective. So do check that out. How big is a Wireshark market? Interesting. This topic came up in the past, and we don't know. I can tell you, though, that there are millions of unique visitors that come to Wireshark every month. So extrapolate however you wish. Okay, so there's some Mac-related questions that it's outside the scope of this book. Okay, the other question is, where can I find preceding webcast recordings? Obviously, if you're watching and listening to this Q&A session, you found the playlist on my YouTube page. Okay, next question comes to us from Joseph. And learning about SSL decryption. So this is an interesting topic. You'll notice in the webinar I said I want to have some guest speakers. And one of the guest speakers, other than Jasper, that I want to have on is also Saki. Saki is the developer, one of the core developers that wrote the SSL dissectors. So in the meantime, if you can't wait, Google Saki, that's S-A-K-E, and SharkFest, SSL, and you'll get to his presentation. Okay, highly recommended. But I think it would be a great idea for me to bring Saki on board for a YouTube session so that we can go over some SSL specific workflow. All right. And then Art had a question, is the book published yet? I can't find it on Amazon. Of course, you're not going to find it on Amazon because I decided to ditch the book in lieu of doing these YouTube sessions. Okay, there's a couple of questions about animation on the PowerPoint. Go ahead and download it. It'll be up on the box.com, and you'll be able to follow along with the video so you can synchronize it locally. I didn't realize that some of the animations were not being shown over the webinar session itself. Okay. Next question is from Michael and says, it sounds like a window size behavior. Sounds like a sliding window, and where there is some continuous flow, not a full stop until all the packets in the windows have been received. So keep in mind what I said about TCP being a stream-oriented protocol, right? That's a textbook definition of TCP, stream-oriented, which means there is no beginning, there is no end. Okay? Once TCP opens up a socket, it's up to the application to dole out how much data it wants to push to the other side. TCP's only job is to have a reliable delivery of that content. So the sliding window and this topic that we discussed in the webinar is actually different. Okay, it's different because in this case, in fact, I'm going to show it to you here. This came up during the webinar itself, but notice the SYN packet, the 10.10.10.10 guy says, look, my window size is 64K. All right, and the 192.168 guy says, all right, I can do 36.574, and it looks like there's no window scaling going on, which means that we have completely adequate window size TCP wise, yet the application is unwilling to fill up the window size, and therein lies the crux of the problem. Even though I have more room for passengers on my train, the conductor or the application won't let them on to the track to get onto the train. And that's the part of the webinar that we discussed, where you see these push packets and constant push packets like you see on the screen here. And that's the application dictating how much it wants to dole out. Let me give you another analogy. Imagine if you had a swimming pool worth of data to move, and you have two choices. You can use a bucket and bail that swimming pool as fast as possible using a bucket, or would you like to use the giant buckets that firefighting helicopters use? I know I'm going to sign up for that giant bucket because I can empty out a pool fairly quickly using that giant bucket that the firefighters use, as opposed to a handheld bucket. Okay, so the size of the bucket is not just determined by TCP window size. Yes, TCP window size plays a role. However, the bucket size that we're talking about is the application. How much is the application willing to dole out those data to be streamed, to be transmitted across to the other side? Okay, so again, while it's related, it is not a sliding window problem. All right, so is the auto-tuning the same as a sliding window size? And someone already posted, and this comes to us from Michael. And yes, it is. Auto-tuning just means that the window size will scale up and down to provide the most efficient amount of the ability to fill the pipe as efficiently as possible. But be careful. Too much of a good thing is a bad thing, right? Remember the old adage, dosage makes the poison. So if your window size is too aggressive, what you're going to end up with is you're going to swamp the network or switches or some device along the path or circuit along the path, and then you're going to crash, and then you're going to try to ramp up, crash, etc. So Google TCP sawtooth congestion, and you'll see exactly what I'm talking about. Okay, next question comes to us from Corey. And the question is, what about tuning MTU and MSS on the network equipment? So MTU, you shouldn't really mess with the MTU with one viable exception. Okay, if you are using MPLS and you're using IPsec or GRE tunnel-based IPsec, then, and if the carrier supports it because it's a gigabit handoff, you want to make the MTU 1600 on those router interfaces. The reason why you want to make the MTU 1600, and assuming the carrier will support you on this, is because this way, the 1500 MTU of an Ethernet plus the additional header required for IPsec and GRE tunnel will fit nicely. All right, so you don't have to worry about PathMTU discovery. And the next one is, what about changing maximum segment size on a network equipment? So we all know that Cisco router, for example, has the command that allows you to strip out and munge. As the SYN and SYNAC packets go through the router will actually go in here and change the MSS size. While that is a technique, I am not a fan of it because I feel like you're asking the routers to do more. We have what's called PathMTU discovery that was developed to solve this problem. In the future sessions, you'll see how that can lead to some issues on routers, but for the most part, I prefer to leave it to PathMTU discovery, which, and if you're not familiar with it, you can A, Google it, and B, wait for future sessions where I will go over some tricky PathMTU discovery techniques. Okay, the other one it comes to us from Matthew, and or Pascal, I should say, and we answered this in the webinar, but I'll just hit it real quick. How do more buffers in the routers give you more bandwidth? Again, remember, if you're allocating more buffers, TCP, you're basically using queuing technique, right? So think about it this way. When you go to airports, this is especially true in the New York metro area. When you go to the airports and you're going through the TSA security check line, what do? Do they give you a straight shot to the security? No, they add buffers using those little roping devices, right? And they make people snake back and forth. And how does that impact the line of the queue? It's longer, but it uses the same size of the room. Okay, so Disney World, any amusement park uses the same technique. They make people snake left and right to accommodate more users than was originally intended for. The buffers do the same thing, and this is why the buffer gives you more bandwidth, essentially. Okay, the TCP thinks that you have more available bandwidth because you haven't heard feedback in the form of retransmission. Okay. The other one is a receiver needs to acknowledge every 2 full-size MSS packets. And the answer is yes and no. So in the Linux, Unix world, it is 2 full-sized MSS that gets acknowledged immediately. In the world of Windows, it's any 2 packets, and this comes about because of slight misunderstanding when you read the RFCs. Okay, if you're really up to it, I'll leave that as an exercise for the reader to find out where in the RFCs it differed. Okay, or the other way, I'll give you a hint, is if you read Stevens and if you read Comer, that deals with when to acknowledge, they differ slightly as well. Again, I'm assuming because of the RFC. The other question is regarding buffers. Okay, and don't buffers simply add to the round trip time since they are being delayed in being sent and received, and the receivers cannot acknowledge until received? The answer is yes. There's a microscopic delay as buffers, but remember we're talking about wire rate transmission here. So technically, yes, buffers elongate the round trip time, but it's orders and orders and orders of magnitude smaller compared to milliseconds that we measure, right? So if your buffers add nanoseconds and microseconds, does it really matter when you're dealing with milliseconds of latency? Okay, the next question is ECN echo. For the most part, David, you can forget about ECN echo. No one uses it, so that's a non sequitur. David comes to us and asks, does Windows auto-tuning really work? Well, that depends. I think it works well. There were some initial implementation challenges perhaps, but for the most part, most people leave it alone and it's fine. So I'm going to chalk that up as yes, auto-tuning does work. For the most part, you probably don't have to worry about it. If you're getting to a point where you think you can do better than auto-tuning, and in some cases you can, it does take experience to be able to do that. Okay, so make sure you really understand what it is that you're doing before you muck with the registry settings in Windows to disable auto-tuning and go with your own. Okay, the next one comes from Jose. The question is in frame 8, 9, and 10, is that examples of full packet time latency? I think the question is, okay, if you look at my delta time from here, so let's make this easier. I'll show you guys a little trick. What you can do is you can hit Control T or right click on the packet and set time reference. Okay, typically I use Control T, or you can right click on and set it to time reference. When you do that, you'll notice that the word reference shows up and it zeroes out the time from the beginning of capture. So it's slightly easier to see things. And the question was, are these delta times the amount of the full frame? And yes, the answer is, it is examples of full packets being serialized onto the wire. Okay, when I say being serialized onto the wire, it means that these number of bits, remember all these are zeros and ones that need to be transmitted on the wire electrically, and those are represented by zeros and ones. And we're not going to go into the framing, again, beyond the scope of the session, but that's what we call the serialization delay. How fast can you shove it onto the wire? Okay, next question from Mac. Is SharkFest expensive? You know what? That's a great question to ask in the SharkFest community. And the other question is, will SharkFest eventually be offered in East Coast City? Sometimes Riverbed offers a mini-me SharkFest session where I and Gerald go on these road trips. Contact your Riverbed sales folks to see if we have any planned in your immediate area. I'll do the breaking news. In May, Gerald and I are going back to Korea, where I was born and raised, and we'll have a SharkFest session there. Not a SharkFest session, not a full-blown version, but a full-day hardcore Wireshark training session in Seoul, Korea. Okay, and Jeffrey had a question about going back to see the SYN packet and window size, which we addressed during the webinar and also earlier in this Q&A session. Okay, Sagar asks, well, do you get a notification when I update the YouTube site? If you subscribe and I post a new video, you do get updated. So the onus is on you, Sagar, to subscribe to the YouTube channel. So next question from Marco. The only way to inform the developer to increase the buffer in his application? And the answer is yes. So in some cases, database being one, for example, you can increase the buffer sizes. Okay, it goes by multiple names. ODBC has a different technique than JDBC. Oracle and Sybase has different techniques as well. In future sessions, I'm going to show you exactly what you need to modify to increase those buffer sizes. Okay, next question comes to us from David. And the question is, what would cause a lot of small packet lengths and not filling the MSS? Well, that's application dependent, right? So there's another segue here, if you will, called Nagel delayed acknowledgement. And I have a YouTube video, 30 minutes of YouTube video on my YouTube channel that discusses this exact topic. Remember, some applications are inherently client-server or push-pull model. I ask you a question, you have to give me an answer back, and it may not fit the full MSS. Okay, that's just the way it happens. Think about a select query. You might make a SQL query that says select star from this table. That right there is just a sentence. I don't know, that's 20, 30, 40 characters. I have no more to send to you, so I'll send the application will send those with a push bit flushing the buffer. The question gets sent as a 200 byte packet or whatever the case might be, and then the query itself generates a lot of data and will be full-size MSS. So it's 100% dependent on application. Okay, another question, more of a comment from Mark. This would be a definition of deep explanation of how TCP work vis-a-vis packet analysis. The answer is yes, but hang on to your seats because you ain't seen nothing yet, Mark. We're going to go much, much deeper in future sessions. We're just slowly building up. Okay, another question from Shalom is, I mentioned ACK after 2 full size or ACK after 2 packets. I addressed that earlier. Can you explain what you meant by that? So again, when the RFCs were written, they realized that you can't indefinitely wait for an answer or an acknowledgement, a positive acknowledgement that the data got to the other side. And so as the RFCs were written, for the most part, they said, you should not acknowledge every single frame that's coming in because that seems kind of wasteful. They settled on 2, but don't wait more than 200 or 500 milliseconds. Meaning, if I only get 1 datagram from you, okay, I get 1 packet from you, and I'm waiting, because remember the RFC says you have to acknowledge every 2 full MSS packets or 2 packets in the case of Windows. And I'm waiting because I only got 1. Do I wait forever before I acknowledge that? No, you don't wait forever. You're going to give it some time. A timer expires, 200 milliseconds, let's say, and then you're going to acknowledge. The perfect analogy that I can give you, and some of you in my Wireshark session have heard this analogy. When you are a bus driver and your manager, your supervisor says you must hit every stop on time every time. Okay, you pull up to the first station, you see some passengers, you open the door, you're getting nervous about meeting the time schedule, so before the passengers all get on, you slam the door shut and you go to the next stop. So while you might have hit every stop, you got some pretty upset people because you didn't fill up the bus, right? After all, the bus company, MTA in case of New York, they're not going to make any money if all the buses are only half full. So the next day, after getting chewed out by your supervisor, you stop at the bus station and you sit there, open the door, and you wait. Because now the priority is filling up the bus. The problem is there are no passengers. What do? Do you sit there all day? You could, but then chances are you're going to get fired. So this is the reason why TCP has timers everywhere. There's a timer after you transmit, because if you don't hear anything back, you have to retransmit. It's called a retransmission timeout. And then, of course, on the acknowledgement side, you have the delayed acknowledgement timer as well. None of this is exposed in the packets. The only way you can see it is if you're writing the program or following the TCP stack, for the most part, which is now done through the network card. How can you get additional webcasts? So this comes from Denny. Again, subscribe to my YouTube channel and you'll be able to get alerts. Pros and cons of using expert analysis. I will show you. So you'll notice that in all of my sessions, I rarely, if ever, go to the expert screen. There are times that I may do it, but I tend not to use expert engine because I don't know how else to say this, because I have 20 some years of doing this. And after a while, you kind of get a sixth sense for where you need to look. The one thing I will caution you, okay, is that when you're looking at expert windows, these are all RFC driven, absolute timers, and etc. So sometimes it can lead you astray. So for example, and this is a perfect use case, can Wireshark determine if the delay is caused by the application or some user who's distracted and not clicking on OK in a message box before the rest of the data is transmitted? Of course, Wireshark can't know. So this is some use cases where, again, the expert engine can lead you astray. When you're starting out, have a healthy dose of skepticism going, and then investigate and tread carefully. Okay, and also ask at ask.wireshark.org or at SharkFest, or shoot me an email. Happy to help you guys out. Okay, the other one is, Riverbed worried at all about high-speed infrastructure such as Google Fiber diminishing the need for one optimization product? And the answer is absolutely not. The more bandwidth, the better it is for us. But again, it's outside the scope of this discussion because it doesn't have anything to do with packet analysis. So I'll punt on that. What is the title of your book? And it was called The Art of Packet Analysis, and now it's on YouTube as part of the webinar. Because to me, it's true, there's more art than science to packet analysis or protocol analysis even today. So the next question from Mark. I get this question quite a bit. And the question is, where would you recommend someone start in the journey to become expert protocol analyst or packet analyst? The answer is RFCs. You must read the RFCs. You must read Stevens, okay? TCP/IP Illustrated by Stevens, Volume 1, and or, preferably read Douglas Comer's Internet Working with TCP/IP Volume 1. These are the de facto industry Bible when it comes to TCP, and I would start there. The other one is, and it sounds cheeky, but it's not. Whenever you have time, do some packet capture. When you're uploading files to YouTube, when you're downloading videos from Amazon, when you're watching Netflix video, do some packet captures. The more you see the packets in Wireshark screen, the better you are at building up the library of information you need to spot troubles or spot errors or spot places in the trace file where your brain will say, this is odd, let me take a look. Okay, so it's all about practice, practice, practice. So the answer is, I guess, the same as how do you get to Carnegie Hall? Practice, practice, practice. All right, next question. How does a sender learn how much the receiver can take at a time? Remember when there's a handshake on SYN/ACK, there is a receiver window size. So the window size that you see here on the screen is the receiver's buffer size. Think of this as how much rope space they have, or that little snaking queue that allows you to buffer. Okay, so the receiver, 10-dot receiver here, can accommodate 65528 passengers or customers, and 192.168.1.1 says, hey, I can receive 36,574 customers. And don't forget that TCP is a duplex, meaning you can send and receive at the same time. So a little tip for you guys, when you're doing this for the first time, always concentrate on one side. Don't try to analyze the sequence numbers of both the sender and the receiver at the same time. I can almost guarantee you'll get wrapped around the axle and get confused. Okay, so take it from one side only and analyze the sender sequence number on one side and the acknowledgement number coming from the other side. Go ahead and ignore the sequence number from the other side because, like I said, you'll get confused very, very quickly. Where do you adjust the window size? It's on the operating system, operating OS, or the network card. Windows or the routers have nothing to do with TCP window size. Okay, the next question is, since I'm using 1.10, I may want to use flags as a column. So yes, absolutely. And I have different workflow on how to spot these, and you'll learn them as we go along. And remember, there are no wrong answers or right answers, okay? Different people have different techniques, and they're all valid. It just depends on what you get used to and how efficient you should be. And that's one of the goals of my session is I want you guys to become efficient, hyper efficient in fact, because it's not unusual for you to look at 200,000 packets on how to do these types of things. Okay, the next question comes to us from William on how to communicate these sorts of findings to management. So I'm going to do another session where our commercial product absolutely helps you in messaging this, and the other one, so stay tuned for the second part to this webinar. It won't be a webinar, it'll just be a YouTube video, so subscribe, William, get the notification, and you'll be able to, I'll answer this question in more detail. So I got a question from Paul about StreamGraph. TCP is grayed out. Make sure you're on a TCP packet with some data in it, and you should be able to use statistics Stevens graph. Otherwise, if you're on a UDP packet or an Ethernet frame, you will not. The TCP Stevens graph will be grayed out. So the next question comes to us from James. How can devices in the middle impact window size? It's not so much the impacting the window size. Devices in the middle can drop packets, and that causes the recovery mechanism and the send windows to drop. Meaning, When there's retransmission, the sender slows down. Okay? So the analogy that I'll give you is that you're on the Autobahn, you're fifth gear, you're cruising along, and all of a sudden there's congestion up ahead. In TCP world, that would be signaled by packet loss. So what do? You slow down, you hit the brake, and you're going from 200 kilometers to 100 kilometers on the Autobahn, which is not unusual. And to do that, you need to downshift, right? So that's what TCP does. Okay, so it's not so much that it's affecting the window size, it is affecting the sender's ability to send more data. Okay, next question. So this goes back to auto-tuning, sawtooth graph that I mentioned earlier, and QoS congestion using WRED. And the answer is yes, all of these QoS mechanisms are built to not have the global synchronization or collapsing, okay? But it solves a different problem individually, with or without these QoS techniques and queuing techniques. You're still going to experience congestion. What the queuing and QoS techniques bring to the table is the global synchronization that can occur where all the packets are ramping up and they all crash at the same time and ramp up and crash, etc. So while they're related to one another, they're slightly different. Okay, next question comes to us from Allison. I noticed that if I'm not doing anything with the server, the window size becomes smaller. So that's interesting. So I don't know, I have not seen a case where what you may be experiencing, Allison, is actually the auto-tuning kernel that's at 8,000 window size because you're not transmitting anything, okay? And auto-tuning kernels tend to start out at 8K, so perhaps that's it. If not, go ahead and send me a trace file and I'll take a look at it for you. And next question comes to us from David. Will I be doing something on the Riverbed Packet Analyzer, or formerly known as Pilot? I think Pilot is a much cooler name than the generic sounding Packet Analyzer. The answer is absolutely yes. It's one of the, the chainsaw that can shred through millions and millions of packets. Yep, sports fans, you heard me right. Pilot, or Packet Analyzer from Riverbed, can shred through millions of packets, tens of millions of packets in fact, and can do analysis on it, and I will show you that in the future. Okay, next question comes from Jim. How would you recognize switch buffer being overwhelmed? So this is a slightly nuanced answer because most switch vendors give you CLI access to counters. Now, there are instances that the counters are not exposed because they are at the ASIC level. And so the reason why this is a nuanced answer is you may have to ask your SE of a particular the switch vendor that of your choice and say, hey, how do I get access to some low-level granular counters specifically related to daughter cards, FPGAs, or ASICs? And if the answer is there are none, then you can look at it from an interface perspective to see if you're dropping packets. That goes back to the CLI. The other way you can do that, okay, is to create two span sessions onto the same Shark appliance. If you can account, okay, think about a switch being in the middle and you have a cable going in and a cable coming out. Okay, so think of this as a transit switch. And you have switch coming in and then you have switch going out for the uplink. If you can account for every single packet going into the switch using a Shark appliance, and you can account for every packet going out of the switch, and there's a difference between the two, then guess what? The switch dropped the packet. It's easy as that. Same workflow as when you're trying to figure out if firewalls are dropping packets or not. Okay? And in the future, using Packet Analyzer, I'll show you how easy it is to use what we call multi-segment analysis. So another question from Matthew about getting started at packet analysis. I already talked about the RFCs and the two textbooks, and at the risk of sounding like self-centered or egotistical, stay and watch SharkFest videos and watch my YouTube channels because it's meant to teach people how to do packet analysis. So how does bandwidth throttling work? At the easiest level, it's about not giving or starving out the acknowledgements. Okay, so when you artificially not, or if you artificially delay the acknowledgement, the sender has no choice but to back off, assuming because it thinks that the packet was lost, and it will go into congestion avoidance, which if essentially means that it's going to throttle down and slow down sending of those packets. Okay, different stacks, Reno, Trino, Vegas, etc., have different techniques, so you can Google that and read about it if you're more interested. So there, another question from a different question from David: is it an application issue if there are thousands of keep alives? No, not really. Keep alives is TCP keep alive is a method used by TCP to ensure that the socket stays open. Technically, you don't need it, but there are some cases where garbage collection says, "Hey, this socket's been opened for too long, and I'm going to shut it down." Devices in the middle, like firewalls, are notorious saying, you know what, I'm not going to allow a long-lived TCP connection. So what do? From a TCP perspective, how do you influence that data? How do you keep that data flowing when it's the application's job to give you the data, right? Keep in mind. So in the webinar session, I talked about how TCP is like a warehouse. And as you send data onto the wire, you Xerox copy it and put it on the shelf. That's your send buffer. And if packets get lost, you go to your warehouse and make another Xerox copy, and this is how TCP guarantees delivery. Okay. If this doesn't make sense, go back to the webinar and listen to that part of the section. Now, TCP keep alive, all you have to do is take the last byte that you transmitted, and you resend that same byte, 1 byte, typically. And the other side will have no choice but to give you a duplicate acknowledgement saying, hey, I got this already. And so this is how TCP forces data onto the wire, even though it's the application's job to give you data. Essentially, TCP cheats and recycles old data that it has in its warehouse to generate feedback from the other side. So if concurrent applications are running, what is the optimal window size? This is where experience counts. You obviously don't want one person to monopolize the link, okay? And so the rule of thumb is there is no rule of thumb. If it's a common core, it's best to start out and talk to the developer saying, what is the SLA you need? And typically you're going to get as fast as possible, and that's not good enough, okay? So try to work the problem backwards. How much data do you have to send, and how fast do you need to get to the other side? And guess what, sports fans? Riverbed is in the business of making that transfer go faster. So I'll give Riverbed a shout out here. Talk to your Riverbed sales team on how we can get that transfer going through there faster. The other one from David is, I thought this was 1.5 hours. Again, I explained the confusion in my earlier preview when I posted the webinar. So take a look at that. Okay, we're finally on to our last page of questions. A lot of thank yous from a lot of people. I truly appreciate it. Thank you for the feedback. More importantly, if you'd like to see something change, please let me know as well. Okay, next question. Final question comes from Chanson. And the question is, where am I coming up with the value of 1390 at packet number 1316? So let's go to packet number 1316. All right, so let's go ahead and hit, we can scroll down but we can hit Control G. That tells you which package do you want to jump to. Here we go, 1316. And I said the value of 1319. Notice, in the length, it says 1456, okay? But that includes all the Ethernet and other headers. So the length that I'm interested in is in the TCP control protocol, the TCP section, and the data, this is how much data TCP is carrying. This is what makes up the application level data, okay? And this is the 1390 that I'm talking about. Let's look at packet number 1317. With all the Ethernet and all the other headers, it's 1382, but in TCP world, once you take away the Ethernet and the IP and even the TCP headers, you'll notice that the actual data is only 1316. So that's where I'm getting those numbers. Okay, again, thank you very much. Stay tuned for additional sessions. There's a webinar coming up. Check the link that you signed up. Obviously, if you attended the webinar, you know where the link is. And number 2, look out, subscribe to the YouTube channel, because I'm going to take this trace file that I used on the webinar and go into it a little bit deeper. But it'll probably take me about 2 weeks to get to that. All right, thank you very much. And if you ever see me on the road or at a seminar, come up and say hello. Thanks.